Now this is a question from your textbook. Question 19 or 10. I can't really see the number here. A liquid flows from container A to B. The volume in cubic cm of liquid in the containers A and B at a certain time t are given as so. And A, B, C, P, and Q are constants. Now they're asking you, is BT a polynomial? Explain. Okay, so let's take a look at BT. I've written the BT here already. Now if I were to expand this, I can actually conclude that it is a polynomial because it is made up of, or is a sum of terms in the form mt to the power of n. Now this t is a variable, something like your x, and the m is a constant. Constant means can be positive or negative lah. So when I say it's a sum, right, it can be something minus, let's say, t square. Okay, so that's what we mean by constant. And although I use the word sum here, it can be a minus something because this is a constant. And the important thing is that n is a whole number. You don't see any 1 over t. You don't see any like square root t. If you have this, then according to what you learn in indices is power half, right? Okay, so power half is not a whole number. So all these variables t, okay, up to here is actually t to the power of 0 because it's a constant term. And t to the power of 0, this 0 here, this power here is a whole number. So this satisfies the condition of being a polynomial. Okay? Next. At the start of the experiment, container A has 300 cubic cm of liquid and container B is empty. Find the value of P and Q. Now what does this mean? Whenever you see at the start of the experiment, what you need to do is to set or let this t be 0. So AT, which means A0 is equals to this one 0, so that means 0. So your P equals to 300. Okay? Which means that your P, you see, this is 0, this is 0, so your P is 300. Finish already, you have found P. And you are told that when T equals to 0, the container B is empty, the volume, which means that this B0, I submit 0 here, this whole thing is 0, I submit 0, this whole thing is 0, I submit 0, this whole thing is 0. That means your Q is equals to 0. That's it. That's your P and Q. And for part 3, explain why this 300 minus AT equals to BT for all non-negative values of T up to, up to the instant when the container A is empty. So what they're trying to say is, you read the question again. Liquid flows from A to B, right? At first, liquid A is 300. Okay? So you have liquid A having 300 cubic cm of liquid, and then the liquid flows from A to B. So don't you agree that your A volume plus your B volume must be equals to 300? And when I make B the subject, why I make B the subject? Because in this case, if you look at the right hand side of the equation, B is the subject. Okay, I get this. Alright, so the explanation is here. At any point in time, volume of A plus volume of B must be 300 because there is only 300 cubic cm of water at any point in time for the two containers. Now we move on to part 4. Okay, find A, B, C. Now how do you find A, B, C? You make use of this part here, this condition that they're giving you. So I sub in this right hand side put here. Okay, then I sub in this AT from the earlier part. You see the earlier part, okay? And I already know that this P is 300, but this minus here multiplied by this will be positive, multiplied will be negative, multiplied will be negative. Okay, and then this 300 minus 300 will cancel off, leaving just this on the left hand side. On the right hand side, I just simply expand this part here, expand, okay, this bracket, open up the bracket, and I can compare the coefficient, and I get B equals to 1. Compare coefficient of t squared, I get the other one. Compare the coefficient of t, I get the last one. Okay, so you just basically solving the unknowns in this identity.